Hi everyone, thanks for joining. Before we get started, if you'd like to ask a question at any point during the webinar, you can enter it in the webinar control panel. We'll then answer all your questions at the end of the webinar. So without further ado, I'll hand you over to Martin.
Well, good morning, everybody. And I do understand there are also people from Europe attending, so good afternoon to you. My name is Martin Matse. I'm with an ATS Global, the Global Business Development Manager for data centers. And my presentation is about DCIM and AI integration. So my agenda, so I have some slides about ATS as a company, only a few, our ATS DCIM system, and then I'm gonna go into the Data Center Uptime Institute survey. They do a yearly survey among data centers and some of the results and how to do something with DCIM in combination with that questions asked in that survey. So looking to ATS as a company, we are a global system integrator with offices in, I think, 28, 29 countries, over 1,100 people working for us. And we do all kind of technical, industrial automation projects. So control DCIM, IoT, quality, MESMON, PLM, cybersecurity, both in the IT, but mainly in the OT domain, so IEC 62443, and supply chain automation. So just to give you some idea of customers, so we have over 4,000 customers in the discrete industry, and maybe know some names like Ford and Tesla, Rolls-Royce, Boeing. In the process industry, big names, Unilever, Janssen Pharmaceutical, Coca-Cola, and of course, for me, the most important part are governmental, finance, and data centers. And we have, for the moment, we have around 200 customers using our data center solution. So our offices, you can see we have a very nice spread among the globe, and of course also offices in the States and Canada. I think we have 3 or 4 offices in the United States, if I recall correctly. And these are some of our data center customers. You maybe see some names which are familiar to you: Microsoft, Facebook. You might know them. Equinix, Digital Realty, Amazon. So we have some very interesting, nice companies as customers within our data center group. We have developed our own DCIM solution. Sorry, it's going the wrong way. So if you look to our DCIM solution, actually it's one big integrated solution, which is flexible and scalable at all sizes. So if you look to the functional modules, it's energy management, cooling management, building management, and visualization, everything else of that. But like I say, it's one solution. So you only choose the functions you want. So you don't have to integrate energy and cooling and building if you want to have a single glass into your data center. And next to that, we built all kind of tools to make that device monitoring more interesting. So performance management, capacity management, failover management. The invoicing is a very important part. We do a lot of co-location sites. And then we also have, there's also part of the presentation today, a digital twin solution, which is is used for white space optimization. If you are an enterprise company, then you need also some other software packages like cable management, patch management, rack management, IT management. And those are third-party products which we can integrate in our own solution. And on top of it, we do a lot of integrations to maintenance, invoicing, CRM, ticketing, workflows, or whatever. So our solution, together with all that our partners are delivering, form a complete DCIM suite. So if you look to our solution, it's open, it's industrial, it's reliable. I think we support every available industrial protocol. But if you look to the data center market, it's mainly OPC, SNMP, Modbus, and BACnet. So those are the most used protocols. Of course, we have sometimes some Profinet or KNX or whatever, but we do support all those software protocols. So we don't need a hardware converter from BACnet to Modbus. It's just bringing a protocol on IP, and we can talk those different protocols to those devices. It's very scalable. It can become very big, very small. If you look to the major group of our customers, it's mainly large size and some medium size. And I think we only have about 4 or 5 small size data centers. So it's mainly in this area. And our biggest customers, well, that's wrong, is 50,000 assets. So it says 5,000. It has over 1 million data points and 30 users. And this is our real secret. Sorry for this. this is our real secret. So instead of deploying a DCIM suite manually, we created a rapid development tool. And in this rapid development tool, there are over 1,400 different building blocks available. And with this rapid development tool, we can easily and fastly deploy a DCIM solution. So for example, here a Schneider PM800 is just one of those building blocks. And if you want to monitor a power meter from Schneider, this type PM800, you only have to fill in the IP address, the BMS code, and the physical location, and then you can deploy it in our DCIM solution. So you have only a very limited knowledge needed to deploy a solution. It's very fast to deploy it, and all those building blocks have been tested in projects. So you're certainly not the first to use it, so we know it's 100% right, without errors, and it will run, it will do what you need. So that's about our DCIM solution. Then the actual subject of today, the data center survey from the Uptime Institute. So every year in September, they produce the results of the survey. So last September was, of course, the 2021 survey. And I think around summer, so around this time, they might send out the questions for the new survey 2022, which will be again presented at the end of September and October. If you look to the companies that are responding, I think it's a global coverage. Of course, with the main group of customers are in the US and in Europe, so that's almost 50% of the companies. And 35% is co-location, 16 telecom, 30 financials, and then we have, of course, those typical enterprise companies who did respond to that Uptime survey. So some results from that survey. The survey, by the way, is freely downloadable from the Uptime Institute. You just fill in your email address and so on, then you can download it and read it for yourself. But as you might know, that the most important metrics in data center is called PUE, which is power usage effectiveness, which is the total power divided by the IT power. That's the major metrics they're using, and that have been installed since 2013. It has become more or less stable, so it has flatlined. At the moment, we see that the edge data centers are expanding, are growing. The density in racks is rising. So in 2011, it's 2.5 kilowatt on average, and 2020 is already 8.4 kilowatts. So that will have some results on your cooling and your capacity management. It's increasingly difficult to find data center staffing. So a good solution supporting you is very important. And if you look to the outages, well, the actual total number of outages are more or less stable, but the increase, the impact increases continuously. And data centers do realize that the causes are more consistent, and they could have been prevented if they had more information. And of course, people and power are still the biggest issues if you look to the outages. If you look to the other challenges that data centers see for themselves in the future is stricter regulations on design, power usage, and reporting. Of course, environmental impact should be decreased, and that is an increasing demand. I said it before, less availability of workflow, and KPI are becoming more and more important. So customers, legislation want to know more about PUE, about performance of data centers, decreasing cost, decreasing space, increasing performance, capacity management. I think that's an area in which is still a lot to gain, but capacity on floor space, on power, on cooling, on connectivity. And of course, that should be not increasing, but that's the risk, that's a challenge, that the outage risk is increasing, but so the number of outages and the effect should be decreased. So one of the questions that was asked to data centers from how do you think that DCIM, data center infrastructure management, can help you to improve your operation? Of course, the very first thing was mentioned was to reduce the risk of an outage, reduce the risk on downtime. So also reducing waste, unnecessary over-provisioning of cooling, power, space, and IT. And it should give you a better overall insight on performance and requirements. Capacity planning is very important, but so it's reducing or really planning your capex and also controlling your opex. optimizing your energy consumption, and of course, increasing efficiency by automating time-consuming tasks. And of course, more and more customers, and if you have big cloud providers as customers like Amazon or Microsoft or whatever, they want to know more and more about the status of your data center, your KPIs, and they would like to be informed real time. Okay, looking to the part of reliability and outages. So I told you before that if you look to the number of outages, you can see here short, severe, serious, significant, minimal, and negligible. You can see that the number of significant, serious, and severe outages are remaining more or less stable the last couple of years. So it hasn't really been changing. But the cost of an outage is more or less increasing. So, and the severe are having a cost over $1 million per outage. So how often does an outage occur? Well, there's a very nice website called the Downtime Detector. Then you can find all outages real time. And if you look at that detector, you can see that in average, and there's also they have around 18 major outages every hour. So it's quite a lot, and it's not only small companies. So if you look to this list, it was just one screenshot. Let me see. You can see United Airlines, TD Bank, American Airlines, Delta Airlines, Bank of America. So there are also big companies who are suffering an outage in those times. And here are some ideas about the Bank of America, United Airlines. So people are not able to check in. 8% flight delayed. You can imagine how much the cost will be. And of course, if you're not able to pay or do your banking, that will be a serious issue. And this was an outage at AWS, so that's the Amazon cloud at Frankfurt, and it lasted for several hours. And many applications again are running on AWS, so they will also suffer the result of an outage. So if you look to the report, so what are the most mentioned reasons for an outage? It's first of all human errors and procedure errors. So and the next step was power. So power, which are a result of limited capacity management. So UPS problems, transfer switches, and gensets. So looking to the biggest issues, humans and power. Just to give you some idea, this is a data center, and this is a new data center, and it's very straightforward. So you have a power distribution unit at the wall, defining your power. You can see plug 1 is going to rack 1, plug 2 is going to plug 2, and plug 3 is going to plug 3. It's very straightforward. So these are the PDUs. There's also PDU. But as you might know, if you have a data center, there are modifications every day, and there are quite a lot. So after a couple of months, your data center will look like this. So this one has 2 PDUs, so they have some redundant PDUs. This one needed more power, so there's a 3-phase PDU instead of a single-phase PDU. And this rack is split into 3 different customers. And all those modifications, well, like I was saying, they are done daily. So looking at just some ideas, what do we see? Of course, this is a little bit exaggerating, but this is what we have seen in different situations. So that redundancy is not used. So everything is connected to one side. PDUs are attached to wrong feeds in bus bars. So there is a very big imbalance in using of bus bars. And as you can see, here are 2 bus bars with L1, L2, L3. And we see that devices are attached to wrong feeds on the bus bar, which is not a problem in this real-time situation. But if you have an outage on one bus bar, your failover will also then result in an outage. And this is what we quite often see at co-location sites, is that people are using power without paying for it. So people forget to connect a PDU Ethernet cable, or they do not attach a contract to a PDU or whatever. And if you talk about money, we've seen in practice that 5 to 10% of the turnover is missed at big co-location sites after a couple of years if you don't really manage this. So what's of course the solution? The solution is bringing everything together and close the loop. So close the loop from contract to rack to invoice, and have some checks and balances to know that is everything correctly connected, Is everything correctly configured? Is not something broken or whatever? So, and DCM, of course, can bring you a lot on this part. Then looking about to data center performance and PUE, power usage effectiveness. So this is again coming from the Uptime Report. And actually 2007 was the year that we started delivering our first DCIM solutions to the market. And at that time, the average PUE was 2.5. So that means that 100 is going to IT and 150 is going to the infrastructure. And you can see that it has been strongly decreasing to 2013, and then it was 1.65, and then it stopped. So if you look from 2013 to now, there haven't been any improvement anymore on the PUE. So what's the reason for that? Well, actually, we think there's also coming from the report, by the way, is that the most easy and expensive methods have been used. So it's about airflow, some optimization, some equipment has been improved. Of course, cold aisle or hot aisle containment is a very big improvement, has been a very big improvement, but that's it. So people data centers don't have a very good idea anymore how to improve the performance of a data center, the efficiency of a data center. So again, from the uptime, so what are for you the most important metrics? And if you look at the numbers, it's IT or power consumption in general, it's PUE, and it's server utilization. But this number is only used by the enterprise data center, so there isn't hardly any co-location site who is any interest in the server utilization, because those servers are from customers. The ones that I also mentioned is water usage, but that's only, of course, people interesting in some country, because water in general is quite cheap. But of course, if you go to Dubai or that kind of countries, then water usage becomes an issue. But besides that, it is hardly ever used for optimization. So talking about that PUE, here's my data center. I have a small data center with two rooms, room 1 and room 2, and I filled in some numbers. And if you calculate your PUE, if you just follow the line, you can see that my PUE is 1.46. So then my boss comes to me and says, "Okay, Martin, you have to improve your PUE, because I think we need a PUE of 1.35 or 1.3 or whatever." Okay, so that's quite a nice question, but this PUE calculation doesn't really tell me what I can do to improve it. So the green grid is the group behind the PUE calculation. They had some kind of PUE decomposition. So now you can calculate partial PUEs depending on the part of installation. So using that green grid PUE decomposition, you can say that the PUE room 1 is 1.25, room 2 is 1.26. Then we have some influence on the IT part, and with some losses part. So if you add them all up, again, you're on 1.46. But now, still, how am I going to improve this? Because, okay, it's quite obvious that room 2 is maybe an issue, but and the total number is a very small percentage. So, okay, what am I going to do to improve this again? Well, one way of doing it, if you have an integrated DCIM solution, so not a BMS and a CMS and an EMS or an EPMS, but just one integrated solution, the idea is that you can bring all the information together, which tells you more about the entire installation. For example, using a balanced scorecard. Now, of course, at the bottom part, we have that PUE calculation. What's very important for many co-location sites is SLA contracts, because colos can lose a lot of money on penalties if they have an SLA breach. So that should be monitored. And at the same time, you can look at your cooling efficiency. So that's called EER or CER or COP. There are different metrics available for monitoring your cooling. And in case of EER, the higher the number, the better it is. So here we can see that my cooling on room 2 is very inefficient. So I should do something on my cooling. At least that's something I know. Then looking to the capacity side, so I can see that my room 1 has an overcapacity, so 83%. So I've lost my N+1 cooling safeguarding. Total cooling is 60%. So in total, I have enough cooling capacity available. So I have some under provisioning on room 2. So by moving apart from room 2 to room 1, I will improve my capacity, but I will also improve my EER. And what else do I see? That I have very low utilization on my UPS capacity. So, of course, how do you improve your UPSs? Well, what we quite often see is that the utilization of UPSs is quite low. So the time they can run on batteries can maybe sometimes 15 minutes, 20 minutes, and people got a very safe feeling because they have a very good UPS capacity backup. But if you look to just a general metrics of a UPS, you can see that if a UPS runs under 50%, it's very inefficient. So it should be running at 70 or 80%, and then it becomes much more efficient. So, of course, you can change, you can buy another type, which has more flexibility, legacy, Econ mode, but it's also having the right capacity available. By just maybe decreasing the part of the UPS you are using, you will improve your UPS efficiency. And of course, as you can see, in the beginning, I said, okay, room 2, the cooling was not very good. So something else we would like to do is improve our cooling efficiency. Now, it's of course a very nice question. What is improving? So suppose I'm in Boston and I would like to travel to New York. And I can say, okay, give me the best way to travel from Boston to New York. Well, people will say to me, okay, that's very nice, but do you want to, what kind of transport do you like to use? Would you like to fly? Would you like to use a train if available? Do you want to go by car? And if so, do you want to have the fastest route? Or do you want to have the cheapest route? Or want to have the most relaxing route? So if you are going to optimize, you also have to know or answer the question on what criteria am I going to optimize? Okay, going back to my data center. So this is our monitoring system with a white space area. Okay, and I like to improve my cooling efficiency on this room. So this is room 1, which wasn't very good. I like to improve. So what are my things I can do? Of course, I can do something with the pressure differential between under the floor or above the floor, or between the cold aisle and the hot aisle. So I can change it to another value, 15, 10, 5 Pascal. So, but okay, what of course, what will it bring, and what are the risks? I can also decide that I would like to change my return temperature, maybe a higher return temperature. Maybe I am willing to reduce my redundancy, N+3, N+2, N+1. Sorry. Maybe I can do something with my tile setup, open more, close more, whatever. Maybe I can increase and decrease my airspeed in combination with a higher or lower water temperature coming from the chillers. Maybe I can move some IT, or I can use more or less crack or CRA units standing at the wall. But so there are all variations I can do to optimize, but what will they bring? Well, actually, of course, they will all bring something, but for me as a human, I'm not sure what the result will be. Of course, I have a feeling what it will do, but I'm not sure. And in that step, we start using AI-like technologies. So if you look to AI, there are different technologies available. You might know them: machine learning, deep learning, digital twinning. Well, if the very most basic one is machine learning. In machine learning, you just put a lot of data, and based on the data, it will slowly create a module saying something about cause and event. But machine learning is limited, that it will only know what it has learned. The same is for deep learning. The way of learning is a little bit more intelligent. It's more a human-like way of learning than machine learning, but still, deep learning only knows what it has seen. So if you have a white space and you're going to add 10 more racks to a white space, or put more power in racks, or fill racks with server, then at that moment there's a new situation, and both machine learning and deep learning has to start learning over again to see what the result is of that change. So another technology that's available is called digital twinning. Digital twinning is a combination of machine learning, deep learning, together with a physical rule set. So it has already data, it has created a module, And if you do something it hasn't seen, then it will use its physical rule set to calculate the result of that modification outside the data he's ever seen. So that's also something we are using in our solution. We call it four-dimensional cooling. It starts with a CFD module for the very first time. And in the white space area, we have all kinds of sensors looking at temperature, flows, and so on. And there can be sensors that are already available at PDUs or at the ceiling or whatever, or maybe add some additional sensors. And then what will happen? We have an IP protected engine, and that engine will calculate a CFD module. Because it measures, it also knows the result, so it will create a CFD module, and it can check the CFD module based on the sensors that are installed. So it will very fast, in the way of machine learning, very fast improve its model. So here is then one of our customers. So this was a Dutch telecom operator, and this is the white space area, and this was the technical area. And the technical area is also used for air mixing, and they only have 3 crack units standing at the wall. And this engine can create a CFD every hour, so it's called the monitoring part. But because it uses the technology digital twinning, it also has what if scenarios. What will happen if? So just to give you some ideas, so this is the CFD module that's created in a stable situation, and you can see we had some small hotspots here. That's it. And then, of course, if you want to decrease energy consumption, one thing you can do is decrease the airspeed of your crack unit. So the question we asked to the digital twin engine, what will happen if we're going to reduce the airspeed on all cracks with 25%? Then it created a new CFD module based on this question. And what you can see is there are a lot of hotspots occurring. So just decreasing the airspeed wasn't a very good solution. So the next step, we asked the module, okay, what will happen again if we decrease the fan speed from the crack unit with 25%, but we're going to also optimize some floor tile settings. And now you can see that all the hotspots are more or less disappearing. And so the picture becomes more stable and the return temperature is much higher. So it's a double win. And what's a double win? That this 25% of fan speed results in even 50% less power on the ventilator. So that's not a linear, but more, I don't know the English name. It's not a linear process. It's not linear. And because the return temperature is higher, the chillers are becoming more efficient because it's much easier to cool the temperature differential from 20 degrees than from 5 degrees than a chiller. If there is a change from cold and hot air from 5 degrees, it's a very inefficient way of running your chiller. So you have a double win, winning on the power consumption on the cracks and on your power consumption of the chiller. And then the next question is, okay, I still have the same situation, but now I'm going to add 42 kilowatt in aisle 5 and 42 kilowatt in aisle 7. So aisle 5 and aisle 7. So these were empty racks, and we're going to add those 42 kilowatts on all these racks in these aisles. And what you see will happen is we see hotspots occurring on row 2 and not over here. And what will be a logical reaction of the person who is responsible for this white space floor? Okay, there are going to be hotspots, so I'm going to increase the airspeed of this unit because I need to cool it down. But then if you ask the question, what will happen in the same instance when I also increase the airspeed, those hotspots are becoming bigger instead of smaller. So what was the real issue? The real issue was that the airspeed was already too high and a part of the rack was not cooled. So the right solution was adding more power in aisle 5 and aisle 7 and decreasing the airspeed on this crack unit. So more power, less cooling power needed. So that's again something which is not very logical, but the engine will help you to make the right decisions. And this was one of another customer are using this. It was another data center. So what did it bring for them? So they had an average, I think they had a PUE around 1.35, 1.36. Sorry. They had after a very short time using our engine, an energy consumption reduction of 25% on cooling. And how did they do it? Well, of course, they adjusted some flows because some flows were too high, some were too low. They adjusted some temperatures. They changed some floor tile settings, and they found some wrong equipment. So they found some equipment which were installed the other way around. So they were blowing hot air into the cold aisle. So this customer had an ROI of only 3 months using this functionality. So it can bring you a lot. Okay, well, I promised only half an hour. So it's now time for questions, if there are any.
Yeah, we've got a couple. First one, I'm seeing a lot of DCIM solutions out there. How do I go about selecting the right one?
Yes, it's a good question. What I normally see happening is, suppose you want to buy a DCIM solution, and because you have a feeling, okay, that will bring me a lot, but how are you going to choose the right one? Then people are starting counting functionality. So that system had 20 functions, that one is 25, that one is 40. Let's go for the 40 because that will offer me the most functionality. And actually, I think in the long run, it will only help you to spend the most money. Because the way you should do it is just ask this question, okay, I have my data center, and what are my issues with my operations? Is it my capacity management, which I need some help? Do I need help on invoicing? So on which part a DCIM solution can really help me? And then if you have those demands quite clear, then you should choose a solution that will fit on those demands, that will help you solve your daily operational solutions. And then we'll bring two things. One, the DCIM solution will be much cheaper than just buying the one with the most functions, and it will also really help you to improve your daily operation. So you should start with the question, why do I need DCIM, and what are my gaps in my operation, and why do we need it for? So that will be, I think, the best way to choose a DCIM solution. And of course, always ask. That's what my advice also be. Always ask for a proof of concept, because, well, sometimes people are promising a lot. That's very nice, but please, if you promise it, let me see it, and just ask them to show them the things you worry the most about. If you have a question about the quality of your invoicing based on your power consumption, just say, okay, show me, how do you do that part of that application? Or if you're afraid of connecting a certain type of device, can you please attach this device? I would like to see it. You just ask for a proof of concept. That's it, I think. I hope that will answer the question. Yes.
And also, are a lot of people already using AI in data centers?
No, it's not very broadly spread, and I think the reason is that people are partly afraid of AI, and so I think we need a new generation for a part, and what we really would like to do is close the loop. So now in our CFD solution, AI solution is showing you a new CFD map, what will be the result. But what we really would like to do is close the loop. So instead of just showing what it will be and advising on set points, we would really like to control the set point. So then the loop is called. So if you look to the process industry, we call it model-based predictive control, and then it will bring a lot. But I think it needs some time for people to accept and adapt that an AI engine can make good decisions, better decisions than humans, and I think with less risks. And people are very afraid of risks, but I think it's the other way around. People are more risks than an AI engine. So I think it will take some time, but in future, I think I see more and more deployments, and more DCIM suppliers are slowly looking at what AI can bring in data centers. Yeah, they will come certainly, but it will take some time. Okay.
Thanks, Martin, and that's all the questions.
Okay. Well, then I would like to thank you for your time. Of course, you can send me an email or call me, or maybe call or email your local representative. And if you want to need help on selecting DCIM solution, we did write a book called Writing an RFP for DCIM, and that's maybe a nice guideline that can help you choosing the DCIM solution that will really fit with your questions. Well, and thank you, and have a good day.